look across Boston and you see hospitals, financial towers, labs, and universities. What ties them together is construction, the industry that creates the physical environment every other industry depends on. In this lecture, we'll map how that industry is structured, where the major sectors differ, and why those differences matter to construction managers. Our focus is practical. You need to understand the industry structure, distinguish the 5 sectors, see why firms specialize, and recognize the organizations and market forces shaping project delivery. Those ideas show up in estimating, scheduling, procurement, risk planning, and career decisions. Sector fluency is part of learning how to manage projects, not just how to describe them. Start with scale. U.S. construction put in place is measured in the trillions of dollars, making it one of the country's largest industries. Construction also contributes a meaningful share of gross domestic product and supports millions of jobs across field labor, supervision, design coordination, and management. Non-residential work alone spans an enormous range, from schools and hospitals to factories, utilities, airports, and data centers. So when we call construction an economic engine, that is not a metaphor. It reflects national output, employment, capital investment, and the infrastructure behind everyday life. Even with that scale, the industry is highly fragmented. Most firms are small, and many operate as specialty contractors or even sole proprietorships. Projects are rarely built by one company doing everything. They are assembled through temporary coalitions of general contractors, trade partners, suppliers, consultants, and owners. That structure makes specialization normal. Firms build knowledge around particular systems, client types, codes, and means and methods. The more specialized the team, the more critical coordination becomes. Someone has to align scope, schedule, cost, quality, safety, and information flow across many independent parties. That is one reason construction management exists as a profession. It responds to complexity created by fragmentation, interdependence, and project-specific team formation. With that structure in mind, we can compare the 5 sectors using 4 questions. Who funds the work? How is it delivered? How large and complex is it? And where does the risk concentrate? That framework helps you move beyond labels and see why residential, commercial, institutional, industrial, and infrastructure projects behave so differently. Residential construction usually relies on lighter structural systems and repetitive means and methods. Think single-family housing, multifamily buildings, and production-oriented workflows. Projects are often smaller than major non-residential jobs. Funding is typically private, and demand is closely tied to interest rates, household confidence, and local market cycles. Because speed, repetition, subcontractor availability, and local product knowledge matter so much, many firms build strong specialization in this sector. Commercial work includes offices, retail, hotels, and entertainment facilities. It often uses steel and concrete systems and places a premium on speed to market. Fast-track delivery is common because owners want revenue-generating space operating as soon as possible. That compresses design, procurement, and field execution. Many projects also separate shell and core work from later tenant fit-out. That creates coordination risk around turnover timing, lease requirements, and multiple stakeholder expectations. Institutional construction covers hospitals, schools, universities, and public facilities. These projects usually involve more demanding codes, approvals, and stakeholder oversight. The building systems are often more complex as well, especially when life safety, infection control, specialized ventilation, or continuous operations are involved. Delivery commonly includes CM at risk and CM agency because owners need early coordination, cost input, and management of complicated stakeholder requirements. Funding can come from public appropriations, private donations, operating revenue, grants, or bond programs. That mix creates continuity of funding risk and heavy accountability. For all of those reasons, institutional work rewards firms with deep sector knowledge rather than broad but shallow experience. Industrial construction includes warehouses, manufacturing plants, semiconductor fabs, battery facilities, and data centers. In this sector, the process often drives the building rather than the other way around. Equipment decisions, utility demands, clean environments, and commissioning requirements shape design and schedule from the beginning. That is why design, build, and EPC approaches are common. Owners want tight integration among process design, procurement, construction, and startup. The major risk is integration. If the process equipment, building systems, controls, and turnover sequence do not align, the whole facility suffers. Infrastructure covers roads, bridges, tunnels, utilities, transit, and airports. These projects are usually defined by public need, public funding, and public scrutiny. Procurement rules matter here as much as field production. Teams must navigate qualification requirements, low bid traditions, regulatory review, and agency processes. Common delivery models include design bid build, CMGC, and public-private partnership structures, each shifting risk and coordination in different ways. The work also happens in active public environments. Traffic, utilities, permitting, environmental constraints, and stakeholder communication all add complexity. At a deeper level, sectors differ by code environment, technical systems, procurement culture, and trade ecosystem, not just by the building's name. A hospital and a warehouse are both buildings, but their mechanical systems, commissioning demands, regulatory exposure, and subcontractor networks are fundamentally different. Those differences affect pricing logic, schedule risk, quality control, and which firms are actually competitive in the work. That is why sector comparison matters. It helps construction managers anticipate how project conditions shape decisions long before work starts in the field. Firms specialize because experience compounds. Repeated work in one sector builds better schedule judgment, stronger production planning, and more reliable cost history. Specialization also strengthens labor relationships, trade coverage, and knowledge of quality standards, safety requirements, and owner expectations. Over time, those advantages become hard to copy. They improve predictability, reduce learning curve risk, and deepen client trust. For a construction manager, that means partner selection is strategic. The right specialist can protect schedule, cost, quality, and safety all at once. Beyond projects themselves, construction managers work inside a larger professional ecosystem. Industry organizations influence standards, training, advocacy, information, and career development. Knowing what these organizations do helps you read the industry more accurately and position your own career more deliberately. CMMLA centers construction management practice through standards, education, and professional identity for managers and owners' representatives. AGC represents contractors broadly and plays a major role in advocacy, workforce issues, and industry guidance. ABC promotes merit shop contracting and emphasizes training, workforce development, and business advocacy. E&R is especially valuable for market intelligence, rankings, and industry reporting that help professionals track trends and firm performance. NECA is closely tied to the electrical contracting sector, where labor relations, technical standards, and specialized trade coordination are central. The industry is also being reshaped by market forces that affect planning long before materials arrive on site. Two of the biggest are labor availability and cost volatility, and both now sit at the center of pre-construction strategy. Across the industry, contractors continue to report difficulty hiring enough qualified craft workers and supervisors. Part of the problem, the workforce is aging, replacement pipelines are uneven, and demand in specialized sectors has intensified competition for talent. When labor gets scarce, wage premiums rise and subcontractor capacity tightens. That changes bid coverage, production assumptions, and schedule reliability. So, labor is not only a field operations issue, it becomes a pre construction issue because staffing reality has to inform estimating, phasing, packaging, and procurement timing. Inflation hits construction hard because industry profit margins are often thin to begin with. There is not much room for error when major inputs move quickly. Steel, lumber, copper, concrete, and labor can all shift enough to undermine budgets that looked reasonable only months earlier. That volatility changes buyout strategy, contingency planning, escalation assumptions, and owner decision timing. In response, construction managers add value through early scope alignment, market checking, procurement sequencing, alternates, and realistic risk conversations with owners. Let's pull the main ideas together. Construction is large and economically significant, but it is also fragmented and deeply specialized. The 5 sectors differ through funding, delivery, systems, procurement, and risk, which is why sector fluency matters in management practice. Professional organizations help define standards and industry awareness, while labor shortages and cost volatility shape current project strategy. In the next module, we'll shift from industry structure to project and organizational structure and look at how teams are arranged to deliver work effectively. Keep these sector differences in mind as you continue. They shape how projects are staffed, planned, and managed from the very beginning.